So I want you to come back to this. I'm going to write it in a different way. I'm going to write it in a different way. Do you remember I said the constants, they're immaterial to this, right? I could name them anything I like. In fact, I don't really need any names here at all. What really matters is the numbers that are attached. Does that make sense? The coefficients? Okay. So let's write down just the coefficients. They're the important thing there, right? So I've got a 3. What's the coefficient of the b in the first equation? 1. It's a 1. Okay. Then you've got an 8 over here. Okay. When I write the second equation, I've got the same piece of information, all lined up in exactly the same way. What are the coefficients? 1, -2, 5. Good. Okay. Now I want to point out to you that with this system of linear equations, right, these 4 numbers are qualitatively different to these 2 numbers. Not all these numbers are created equal. They have a different role here. How would you describe how they're different? How are these 4 numbers different to these 2? Think about it. Their magnitude is smaller. That's true. But I could change the I could make this, I could make that 30 or something like that. And it would still have the same thing that's different about it. It's a bit harder to see now that I've stripped away all of this information. But
are they prime?
These numbers, well, those guys aren't. The values are coincidental. But what's important is that these are attached to the constants, right? They're coefficients. And these guys are not, right? They're just numbers that are hanging there. So to distinguish between them, I'm going to slap a line between them, which is kind of equivalent to my equal sign. Right? Now, here we go. Here's my system of linear equations, but written without any of the algebra stuff. Okay? So to indicate that this is all one collection of numbers, I'm going to put it together like this. We call this thing a matrix. Okay? Now, the plural of matrix is matrices. Okay? Just like the plural of vertex is vertices. You get the idea. Okay. Now I want you to think about this. How can I go about solving this using this instead of using this? Okay. I'm going to need a little more space. What kinds of tools did we use to manipulate these equations in this case? And how would they look when I bring them over here? Okay, so let's have a think about this. I'm going to use this column in a second. This whole system here, right? I'm going to say it's equal to another system that's equivalent. Okay, so I'm going to draw up for myself another little grid where I'm going to pop in all of my numbers. Okay, I can say this is going to be equal to this in a very similar way to, for instance, say that this. Well, where did equation 3 come from? Where did it come from? Look carefully. It's equation 1 times 2. Right? So these equations are the same. Is that okay? Which means that these 2 equations together, that system, is equivalent to these 2 together. Does that make sense? You see that I haven't really changed anything. I'm going to have the same solutions. If I use these as my starting point versus these as my starting point, you'll still get the same answers at the end. You happy with that? Okay. So how would I do that here? How would I translate what happened over here, the tools you're familiar with, the processes you're familiar with, here? Well, you take that first equation, 3, 1, 8, and you multiply everything by 2. Is that okay? So I'll have the same coefficients, 6, 2, 16. Is that all right? This equation hasn't changed down here, though it could if we want to. All right, now, where did we go from here? What happened over here? We were going to add these 2 equations together, okay? By the way, as we're going through this, you're like, this is a bit weird, it's a bit awkward. You'll think of things about this process which are like, this is easier the way I did it before, but I want you to have your mind ticking as to what things are going to be better when we do it this way than others. I can already think of one, even having just written one line. What did Raphael do next? He added them, right? So if I add these 2 together, watch what happens. Okay, I'm going to adjust. Which line do you want? I'll adjust the. I'll adjust this line. Okay. So I'm going to add these 2 together. I'm going to add this one to this one. So that's going to become a 7. That's going to become a 0, and then this is going to become a 21. Okay with that? This equation hasn't changed. You happy with that?
What?
What have I done? What did I do? What did I do? I took this second line and I added it to the first one. Or I took this row and I added it to this one, right? So 1 plus 6 is 7. Negative 2 plus 2 is 0. And 5 plus 16 is 21. You okay so far?
What? So have you figured out that 7 equals 21?
Yeah, so this line here is equivalent to this line. Right? Does that make sense? I'm trying to mimic what was done over here, but in this new form of notation. Right? So this column here, these are all of the A's. Right? This column here, these are all of the B's. And these columns here, these are all of the numbers on their own. Does that make sense? Now, remember, we have this endpoint we're trying to get to, right? We're trying to find out what A is, we're trying to find out what B is, right? In other words, what I really want is for these columns to be 1, right? For instance, I want this to be a 1, not a 7. So what do I do to this row to change that? You divide by 7, okay. So I'm just, actually I can still fit this down here. Okay. Right, this whole first row, divide by 3, that's going to be equivalent to this line here, right? 7, sorry, divide by 7. 7 divided by 7, 1. 0 divided by 7, 0. 21 divided by 7 gives you 3. So far, so good? Okay. What have I got down here? 1, negative 2, 5. Okay. Think. I've already worked out what A is. Right? Already worked out what A is. So now how can I use this row here, the first one, to work out what B is over here? I want 1 to be here. How will I do it? I've got a 1 here, right? And I've got a 1 here. So if I take the first row away from the second row, I'll have nothing here, right? So watch, okay? I've got 1, 0, 3. Okay, so everything in the first row, I'm going to take it away from the second row. Watch. That's going to become 0. Negative 2 minus 0 will be negative 2. Okay, and then this will be 5 minus 3. That's 2. That is, where's that? That's this line. You see that? Minus 2b, he's written it the other way around. Minus 2b, there are my b's, is equal to 2. So I've got my A in the first row. What do I do to the second row to solve it? I divide by negative 2. 0, 1, negative 1. Can you see it now? So now I look at this and I'm finished. I can say, all right, from the first row, A equals 3. And from the second row, B is negative 1. Okay? Now what did I do? In terms of the arithmetic, I did exactly the same thing as over here. It's a bit unfamiliar because we're not used to this kind of notation. But mathematically, it's the same.